Hi all, welcome back to my channel. Today we will look at one of the numerical from distribution. Specifically, we'll look at binomial distribution, a numerical problem. Before I move ahead, I'll strongly request you to subscribe to my channel, share my videos with your friends, peers, and colleagues. So let's have a look at binomial distribution. I'll come to this later, but first have a look at the question that we have for today. It was asked as a query in one of the forums, so I thought it would be good to cover on my channel. So the question that we have been asked is, what is the probability that in a package of 12 tennis balls, two or more would be overweight if the probability of being overweight for a single ball is 10%? What is a random variable here and what is its distribution? Over here, I mean, in the question, it was asked that what is the distribution? It was not actually given that it's a binomial distribution. But to give you a clarity, when there are two outcomes of the experiment, that is, if you choose one tennis ball, if it could be either overweight or it could be underweight. So there are two outcomes. So that's why the distribution is binomial distribution. And the random variable here is probability of getting x is equal to greater than or equal to 2. So that's a random variable. To give you more clarity on the binomial distribution, think of your FRM exam wherein you have got total 100 questions. So my apologies, over here it should be number of questions. So the consider the FRM exam wherein you have number of questions is 100, and think that for just as a random scenario, think that you have to calculate the probability of getting 70 or more questions correct. Then uh, then we have to take into account what is the probability of getting one question correct. That is 25%, because you have four options and one option is correct. So out of four, there is a chance that you would select a correct option is 25, and getting a probability of getting incorrect answer is 75%. So that's how we formulate the binomial distribution problem. This was just a random example. Going back to our original question, we'll just draw this information in this same table format. So there are 12 tennis balls. What we have to calculate is that what is the probability that two or more balls would be overweight, and probability of being overweight is 10%, probability of not being overweight or probability of being underweight is 90%. So this is a formula that we use, but just before we move ahead and solve this question, I would just I would like to explain it in more detail. So what exactly it is asking is, what is the probability that two or more balls would be overweight? So what would happen that there could, number one scenario could be these two balls are overweight. So this is a number one scenario. In the second scenario, these two balls could be overweight. So we can combine this ball with all. I mean, we can pair this ball with all of these remaining 11 balls. Similarly, we can pair this second ball. Of course, there would be some kind of repetition. There is a separate formula for calculating this. How many combinations are possible? I mean, how many number of combinations are could be there if you want to make two pairs out of 12 balls. So this formula this gives you directly that, and it is available in your BA2 plus calculator as well. So that is a number one scenario, and second scenario could be it's x greater than equal to 2. There could be three balls which are overweight. That scenario also we have to cover. So and we can again make a combination of three balls out of 12 balls in a various different way. That would be given by formula 12C3. Likewise, there could be 4, 5, and so on. So this is the same thing that I just talked about. So we are interested in probability of getting two or more balls overweight, but it was I did it on Excel, so it was pretty easy to do this in this way. But in exam, what I would suggest is, so this is a probability which you are interested in, that is greater than or equal to 2. So uh right hand side of this total probability that is reflected by this bar. So this is a question that we have been asked, but in exam it would be a bit of challenge on the calculator to calculate all these probabilities and add them up. So what I would suggest is, instead of just calculate these two, like probability of getting zero overweight and probability of getting one ball as a overweight, and then subtract it from the one. So this is a shortcut. And how these probabilities are calculated, so this is a formula that has been used. So for example, probability of getting balls overweight, so the n is 2 and x is 0. So p is your 10%, so 10% to the power 0 and 90% to the power 12. So that's how this number has been populated. And similarly for 1, it's n is 12, n is fixed, x, your x, that is random variable, keeps varying. So 12c1, 10% to the power 1 and 19% to the power 11. So this addition of these two powers will be always your n. So probability of one ball is 10% to the 1 and 90% we are calculating the probability of getting one ball overweight. So 10% to the power 1 and 90% to the power 11. The rest 11 are underweight. So that's how we calculate these probabilities. And like, yeah, so in Excel it was pretty much straightforward. In fact, we have direct function in the Excel which calculates the binomial probabilities. So what we'll do, we'll just subtract these two from one to calculate this probability. So this total this total is 1. Okay, so even if we calculate till here, so we can subtract 1 minus this portion to get this complete portion. So it's very straightforward. Instead of calculating from all the way from 2 to 12 balls, uh, so it's very easy to calculate these two and subtract it from 1. So it would come around 35%. So, I mean, please do confirm in the channel, in the comment box, that if the answer was correct. And one more observation, being a FRM student, you can make of probability of getting 12 balls as overweight is very nil. I mean, you can see it's approximately 0. If I mimic this statement in our exam example, so probability of getting all 100 questions correct would be very less. Given probability of getting one question correct is 25%. So probability of getting all questions correct would be very less. Being a FRM student, I thought you should make note of this observation. Hope you liked the video. If yes, please do share with your colleagues as well. And please do subscribe and hit the notification button to get more information like this. Thank you very much for watching. Stay connected.